Now, let's find the vertex, focus, and directrix of parabola with the given equation here, which is y minus 2 squared equals negative 8 times quantity x plus 1. Here are the few steps we need to follow. First, you want to locate the center, so you change the form into this way. We have a y minus 2, that's fine. We have a squared here, and then equals negative 8 times, here is x plus 1. You want to change it to x minus negative 1. Then through this form, you can immediately locate x for the center or the vertex will be negative 1. So that's our x, because here is x minus negative 1. So x is this value. And then y minus 2, you choose 2. So this will be the vertex. So right away, you can find out where the vertex is. Negative 1, 2. That will be the vertex. So this one will not be. It's negative 1, 2. This one is 2, negative 1. Okay. And the possibly negative 1, 2, negative 1, 2. Those two might be right. Okay. So this one is 1, negative 2. That's not correct. Okay. So the candidates would be either this one or this one. Let's locate the center or the vertex. Then, once you get that, you can immediately ignore y minus 2 squared. Just let y minus 2 be y squared. Because from here to here is simply shifting by, like here, it was y, then y minus 2 you get there. Okay? And here, x minus negative 1, you change this quantity to just to x. So then, this is the original equation without shifting. This one is easy for us to find where the vertex, this was in the origin, and where the directrix and where the focal point is. Okay, so we want to find out the original equation without shifting. Changing this one to standard form and find p. Standard form will be the exponent is 1, that variable should stand alone. So in this case, the exponent for x is 1, so x should stand alone on one side. Then both sides divided by negative 8. So you have x equals, those negative and positive canceled, and then you have a y squared here times negative 1 over 8. This is the standard form. Comparing this standard form with the one we are given in that 1 out of 4 standard form, we can compare those two and find p. Because, denominator is 8, so 4 times p has to be 8. The rest of them are all the same. Negative, negative. Okay. So here, then 4p equals 8, then p has to be 2, because 2 times 4 is 8. Okay, once you have a p, then you can almost find everything. Originally, you know for this function x equals -108 times y squared. Y squared is positive, so you can either put positive or negative into the y, and then you may mark, oh, okay, positive, negative. And then x equals negative number 108 times y squared is positive. So you get here x all the time has to be negative, is on this side. Okay, then you know once we find p, we can just write the focus right away, which is -2, 0 for the curve without shifting. Directrix is always on the other side, which is x equals 2. All right. Then you know this is the graph without shifting. The graph actually is shifted. The center from origin 0, 0 goes to this place. All right. And then we know previously it was -2, 0 as a focal point. You add the center onto focal point. You have a -1 plus -2. You then get -3. 0 and 2 add together is 2. So you know the focal point or the focus will be -3, 2. The graph is shifted. And then here x equals 2 without y, you simply add this -1 onto 2. So then you have x is 1. 2 plus -1. X value is -1. So you have x is 1. So basically this graph is shifted like 1 unit to the left. You see, directrix is shifted from here to here. And then 2 units up. 1 unit left, 2 units up. Okay, so basically 1 unit left, 2 units up. Okay, if you use the website, which is decimal.com here, okay, you input this function y minus 2 squared equals -8 times quantity x plus 1, you will get this picture. And you can see here the vertex is -1, 2, right here. The directrix here is x equals 1. That's what we get here, dotted line for this one. And where is the focal point? -3, 0. That's 1, 2, 3, negative. And then 2, -3, 2. So 1, 2. So this will be the focal point. Once you plug in this equation at the website decimal.com. Okay? All right. That will be our final answer. I'll see you next time.